Good morning, everyone. Welcome to another episode of Tech Leaders Unplugged. And this is your host, Carlos Ponce. And today we're hosting our guest. And of course, I'm joined, I'm sorry I almost forgot that we couldn't have this episode without, uh, with my fellow teammate, Wade.
Nice to meet you.
And let me just frame all of us here so that we can see that everyone can watch us. So we have Wade Erickson here with us as co-host. And today we're going to be speaking with our guest, Irv Lustig. He is the optimization principal at Princeton Consultants. So, Irv, welcome to the show.
Oh, thank you for having me.
Absolutely. Our pleasure. So, Irv, let's start with you first. So tell us a little bit about you, a little bit about your background, where you're coming from, and then tell us about the company, and then we'll go from there. Thank you.
All right. Yeah, sure. So I've had a long career in my PhD that I received in 1987 from Stanford was in an area called operations research. And my thesis advisor was a famous guy by the name of George Dantzig. He is what's known as the father of linear programming, which started the optimization area back in the late 1940s. After Stanford, I went on to teach at Princeton University for 6 years, developed some new algorithms, joined a small software company called Cplex, which got acquired by a bigger software company called iLog, which got acquired by an even bigger company called IBM that everybody's familiar with. Spent time in IBM, and my career ranged from doing development of software products to marketing to sales. And then at IBM, we were integrating the sales organization. My last few years at IBM, I was in IBM research, got back to my technical things, integrating, looking at areas where we could marry what I do in optimization and other colleagues as well with the then emerging area of predictive analytics. And then I left IBM about just over 8 years ago and joined Princeton. Here I lead our optimization sales and efforts, as well as architecture and implementations of our optimization-based projects for customers that range from over a wide variety of different industries.
Great. Thank you so much, Irv. And what about Princeton Consultants? What can you tell us about the company? How did it all started?
Sure. So Princeton Consultants, actually, we've been in business for over 40 years. The founders were a couple of Princeton University grads. Started off as a management consulting company. And as it evolved, our tagline is management consulting and information technology. So we do a lot of work that has nothing to do with AI, advanced analytics, a lot of work in the transportation industry. All the major U.S. railroads are our clients. So we end up building decision support systems based on software to help them operate their businesses. And then as part of that, then we'll also do some optimization work in other areas of analytics and AI that we apply to help them make better decisions. We have pretty much a special focus in the areas of transportation and rail, as well as in trucking. But then in the optimization, we do everything from finance to healthcare to government. I'm probably leaving out a few as well. Supply chain. I mean, it's all over the place. And one reason I came here is really the management consulting side of the house. Is having been involved with optimization since I left grad school, I would often run into people that said, "I've got this great optimization thing, and it can save my company millions of dollars," but it wasn't getting used. And the reason is that often when you're implementing these projects, and this is true in optimization or for any type of AI project, you have to think about the effects on the organization as a whole. How are their operations going to change? How are people going to change the way they're doing their daily lives? How will the customers interact differently? And that's a very soft skill. So we have a number of people here that are really skilled in these areas. I've learned from them, and I'm getting better at it myself. Things related to change management that are important when you're out there actually deploying these solutions into the business. So we've been doing that kind of work for 40 plus years. I think we've done over this time. I've only been here 8.5 years. We've done something on the order of like 1,800 different projects for a large number of different companies.
Well, certainly 1,800 different projects can say a lot about your experience in this particular field, especially with now with AI that's been around. Well, it's been around for a long time, but these days, in this day and age, there's a lot of word about the hustle and bustle about AI. So we're all looking into what's going on, right?
Mhm.
So I look forward to this conversation, and I look forward to also jumping into the topic that you chose for today's conversation. So the topic, as chosen by you, is the power of AI mastering optimization in your toolkit. So let's start with that. Let's start with the topic itself. Why did you choose this particular topic, and why did you feel it was relevant and for this day and age? Can you help us understand that part, please, a little bit?
Yeah, for sure. So optimization has been around for a long time. As I mentioned, the founder of the field kind of started out in the 40s, and it's one of these technologies that is actually used to make better decisions about you with limited resources, and it's around you every day. You don't even realize it. So, as examples, the airlines all use optimization to determine which planes go on which flights. You don't want big planes on flights with low demand. You don't want small planes on flights with high demand. But then the flights have to connect, right? So if you're, going, I live in Miami. If a plane goes from Miami to Dallas on American Airlines, then where's that plane going to go next? How do you schedule the maintenance? And how do you not only do that? How do you schedule the crews, the pilots and the flight attendants? Um, so another example is if you take a can of your favorite beverage, how did that can of beverage get to your store? All right, there was transportation involved. There are distribution centers involved. It's all part of the supply chain. We've all heard, in COVID about a lot of the supply chain disruptions. The planning of what those supply chains look like is actually all done with optimization. Speaking to some of the kind of projects that I've worked on here at Princeton, we did a project. In coordination with the U.S. Census Bureau for the 2020 census. And I'm going to use this project as an illustration of the kinds of impact that optimization can have. So with the census, it has two parts. We all just went through it a few years ago. The first part is traditionally they would send out a form that you would fill out at your house. In 2020, they changed that to give you a postcard and an internet link. You would go to the internet, you would fill out your form and give your responses for the census. About 60 to 65% of households respond that way, but the U.S. Constitution mandates that every single person in the U.S. gets counted. So the next step is the Census Bureau hires in the past around 500,000 enumerators. In 2020, it was 300,000. That basically go around and knock on the doors of all the people who didn't respond to get them to fill out their response. In 2010, the way this was done is a supervisor of these enumerators would meet them at like a McDonald's or a Starbucks, give them a bunch of cases to work, and the enumerators would then work the cases until completion. Generally, they visit each household 6 times and then they say, I couldn't figure it out. But they work each case, and the enumerators do it on their own time, and they do the cases in any order they want. And they're paid by time and mileage. In 2020, this was changed. In 2020, they used optimization and also some other types of machine learning techniques as well to figure out and say, we're going to give each enumerator on a cell phone and tell him, this is the cases you're going to work, and here's the order you're going to do them in, right? And so what this did is it took out about $2.5 billion of cost out of the U.S. Census operations. They didn't need as many enumerators. The enumerators were twice as productive. They were basically completing twice as many cases per hour than they were under the previous system. And so this was all driven by the fact that optimization was able to give them the best routes and also assign them the work, because within an area, say a county, you've got multiple enumerators. You want to give them work close to their house because they're paid from when they drive from their house to the first place they visit. So you don't want to send an a numerator like I'm in Miami from South Miami to go up to North Miami. It doesn't make any sense. So doing that efficiently took out this cost and made the census a lot more efficient. And then it turned out this was all planned for April 1st, 2020. But we all kind of remember where we were in April 21st, 2020. We were all locked down, as were the enumerators. So the whole enumeration process was delayed until August to October of that year. And what this optimization algorithms, a set of algorithms that were used to do this, basically made the census work. They could not have done it were it not for having this type of automation driven by optimization techniques to deliver that kind of value. And I can go on and on with example after example.
Yeah.
So, but the reason I chose this topic is that a lot of the focus in AI today is in machine learning. All right. And what optimization is about making decisions about your resources and how to allocate them efficiently. So going back to my census example is I've got enumerators. How do I make them more efficient? How do I make them more productive? And so it's kind of the next level after machine learning. Machine learning, in a simple way, I can take an image and say, that's a cat and that's a dog. Well, okay, but once I know it's a cat and dog, what do I want to do about it? So it's really about driving the decisions that come out
Mhm.
and being able to automate those decision processes, whether it's planning allocation or scheduling tasks. All these types of things are done with optimization.
Yeah, well, what I'm hearing is that, and then I'm going to let Wade talk, but what I'm hearing is that the role of optimization, I guess it's kind of supercharging, AI performance and AI systems, that kind of thing, right? So it's kind of on steroids. Okay, Wade, I got a bunch of questions that are popping up
Sure.
into my head, but I'm going to please be my guest.
Yeah. So obviously, a lot of the listeners come from the tech space that watch this show, and we've seen quite a frenzy around AI. AI has been around a long time, but really in the last, I don't know, the Chat GPT and all that stuff has really kind of exploded the interest in AI and inserting that in the software products of that are available through SaaS and those kinds of things. Um, Can you talk a little bit about the process that's involved when you're presented a project, how the optimization goes into maybe the design thinking and the evaluation of the current workflows in the application, and where do you kind of insert your background and intellect into that process, and then how does that show up then in the software development teams to insert the new algorithms and the new models and methods to optimize. Can you talk a little bit about that process and how
Yeah.
you leverage your maybe your in-house talent and maybe look for outside talent? So there's these developers out there that want to get into AI and maybe what they need to do to prepare themselves to be part of a team like that.
Oh, it's a
Hope
big,
that helps.
big, long question there, Wade.
Sure.
So, what we first really look for are business processes where typically people are making decisions in spreadsheets or on whiteboards about allocating their resources. Often in the scheduling area, they're doing things like figuring out a schedule in a spreadsheet and trying to understand how they can jigger things around, etc. It's often manual processes. So we first look at how are they making decisions today, and what data are they using to inform those decisions. So the first step of the process is to say, okay, you're making these decisions, but what information and data are you using? Is the data available? Right? Sometimes the data is sitting in people's heads, right? It's, well, we've always done it this way. I kind of know that, I need to have this customer serviced by this, engineer or what have you on a route or something like that. So we first look at the decision problem, and then what we do is then go out and define and find the data that's going to drive the decisions. Where is the data located, and get it organized, and we write documentation that says here's all data, it's these tables and how they interrelate, etc. And the next step is then we write a mathematical model, and that's kind of the secret sauce of optimization, is you have to have that talent and skill to be able to write those kind of models. The area it's traditionally been taught in is where my degree is in operations research. Now you'll find optimization courses in many business analytics and data science programs, uh, mainly because a lot of the folks like myself who are in the academic world have gone on and said, hey, we got to reorient our programs, but we want to teach people optimization. And there's kind of education you have to get. You can read some books, but the real hard stuff, there's an art and a science to writing a good math model. And what you're basically doing is saying, I have all this data and I'm going to mathematically define my decisions as variables. And then you also write out constraints. How are these decisions constrained? And this is all part of understanding the business process. How to, what is saying if they're allocating resources, well, I've only got, 10 people to schedule. Okay, that's a limit. There's only 10 people to work with, or what other types of limits might exist. And then you also look at typically what's called an objective function. This is the key part of optimizing, is that you define what is it. Maybe we're going to be minimizing costs or minimizing the amount of time it takes to get a job done, or maximizing profits. Have some quantification of KPIs that if we change our decisions, how will those KPIs change? And we all write it out mathematically. Once we have all that documentation done, then we get to the coding part, which is we then use different tools. There's a number of good commercial tools, typically not in the open source world, but commercial tools that allow you to represent these mathematical models, marry it with data, so that you basically, I like to describe it as a big square root button on a calculator. You throw a bunch of numbers in, you get some numbers out that give you that optimal decision. And it's provably optimal mathematically, that you can say, given the way you've set up your problem, there's no better solution way of making those decisions as measured by those objective functions and KPIs. Take those numbers out, and now you're going to use them in some kind of application. We typically start by building an application that has a user interface that is going to allow the user to understand the answer and see why is it making those decisions. And sometimes they want to change the data. So we're doing a project right now where we're doing scheduling of a bunch of different tasks, and there's a certain constraint on how many tasks can be done by different people at over time. So you can imagine it as basically building a big gigantic Gantt chart where you're not exceeding the number of resources. Well, determining the value of how many simultaneous things can be done is a user input. So we have a screen that lets them edit that number, right? They've given us some default numbers, but they can override that. And then they can change those numbers and see what is the resulting new schedule that comes out of it. So the path really starts with understanding the business problem first, and seeing, is it amenable to optimization, and trying to get an estimate that if we are optimizing, what will improve. Sometimes the improvements are, as I said, minimizing costs, like in the case of the census, maximizing profits, or coming up with more efficiency in terms of time. Sometimes the improvement is that you've automated a process that was taking people a week to do that can now be done in a couple of minutes. That's going to change the way they're working, right? So they're going to start working and thinking differently and looking at the world in a very different way, because now they can make decisions faster. So we try to elucidate what those benefits will be up front, go out and then do the steps of defining the data, defining a model, implementation, and then building it into a software application that typically has a database to store the data needed for optimization, a user interface, etc. And then, once people are comfortable with the user interface type of application, we may get to putting it in a black box where it's now becoming an automated decision process. So as an example, we worked with one e-commerce company. What they do is they get a lot of orders 24 hours a day, 7 days a week. They have to determine where are they going to. They have about 15, I think, fulfillment warehouses. When they get an order, they have to say which warehouse should fulfill that order, because they would like to make it. Customers typically order more than one product, and you want to put them all in one box, maybe two boxes from the same place, so the customer gets the shipment on the same day. But you've got to allocate the work. You also have to figure out, well, what happens if this one warehouse doesn't have all 5 products the customer ordered? Is there another warehouse does it? Or do I have to split the shipment? And what are the costs of shipping? If I'm in Miami and they figure in the warehouse that has all my products is in Seattle, maybe it's better to split the shipment into 2 different warehouses that are in Tennessee and Texas and get the product to me that way, because I'll get it faster. So all of this is done with optimization. They solve this problem every 5 minutes. They take a batch of 500 orders, allocate them across all their warehouses to send to the customers. 5 minutes later, get another batch of 500 orders and keep repeating this process, all black boxed. but they didn't get to that black box without doing the experimentation of a user interface and looking at how the KPIs were working over time. So I hope that's a long-winded answer to your pretty long question there, Wade.
Yeah, exactly. That fits it well. Tell me a little bit about the test and the validation of these models and the math. I know you said in that the mathematic kind of proves that this is the optimum, but obviously there's some validation and testing that goes into that, and what's kind of the process there, because a lot of times with AI, it's coming up with solutions that are not necessarily linear. There's so many different inputs that the mathematical model has to crunch. How do you validate and test for that?
This is actually a real challenge. There's a couple of different things that we do. So one thing that we do is when I write one of these mathematical models and define the constraints, one way we test it is we'll have somebody else on our team who knows nothing about optimization write what we call a solution validator. And what the solution validator will do is take the same set of data inputs plus the solution that I've generated and say, does it satisfy all the constraints? And is the objective value, the value of the KPIs, exactly what I was getting from the optimization? So this is kind of a way of checking that one of us hasn't messed up or misunderstood what the requirements are. The second part, which is more difficult, is, are we solving the right business problem? Are we actually giving an answer that makes sense in the context of the business? And that typically is done by multiple cycles with the experts, the people who were making the decisions before, and having them evaluate the quality of the solution. Right. So as an example, in this company we're working with right now in scheduling activities, we do a year's worth of activities. They want to make sure that all of them start by the end of the year. But what happens is our solution says, I can't do that. I'm going to have some that are starting in January. They say, well, that can't happen. Well, then I come back and I do some analysis and I say to them, well, you know what? You were at capacity all the way through January. There's no way I could schedule something into December because you were the people who needed to do that work were at capacity. So you have to do this analysis back and forth. It's very difficult to do like automated testing like we do and typically in software because the values can change, the numbers can change. We can make sure we're doing testing that you try to build out a big test harness of a lot of different data sets and test all of those data and make sure that there's not failures that are occurring, that the answers are making sense, that the answer coming out of the op model is equal to what comes from the solution validator. But doing the formal testing like that we typically like to do in the software development process is actually a real challenge because, as I used before, it's a big square root button on a calculator. So there's a lot of numbers, and just changing one or two numbers can drastically change the solution that comes out. So, we do our best here to try to make sure that we've put in guardrails that will make it so that there won't be a failure. But then again, that's also why we tend to work with applications where the users are involved and their ability to see, and we visualize lots of parts of the solution. When they see these visuals, they're able to say, yeah, that makes sense. Or, hey, why did this happen? And then we have to do some analysis to get an understanding of that.
Great. I have one more question. We're coming up on time, Irv, but I have one more question, Wade, if I may, really quick. For many of us, for most of us, if not all of us, AI is fascinating, and more so given the widespread knowledge that there is out there for us to absorb, right? So, but I am assuming that from the layman's perspective, that it's not all milk and honey. It poses some challenges for a lot of people out there, right? So it could be anything. It could be computational. It could be, trade-offs. So whatever it is. So my question to you, Irv, is this. What sort of common challenges do AI practitioners face when incorporating optimization into their toolkit?
I think part of it is, to some extent, one of the issues with the AI is that we see movies like the movie AI about robots and controlling our lives, and thinking of AI as something that's becoming human with emotions and things like that, and it's a scary thing. In But the kind of AI that I'm talking about in optimization is about trying to automate a decision process, taking something that humans are doing today, or really are very difficult for a human to do, and letting the computer do the work. And so it's intelligent in the sense that it's doing what a human would do, but it's doing it just with really a bunch of math behind it. So what we look at when in terms of getting adoption, what we find is really important is that I don't come out and say, I've got optimization and let me find the optimization problem and I'll solve that problem. I try to look at it in the reverse. I try to say, let me understand your business problems. Let me talk about the decisions that you're making and then seeing if I can apply this technology. And I think that a lot of times with the AI, and we hear about new things like Chat GPT has come up, is the hot buzzword, and generative AI over the last half year. Technology is a means to an end, and I think the important thing is we have to find that end. That is, what is the value that we're going to do, and also understand where some of the risks may be, right? So I think a lot of the things that are happening in the machine learning and in the generative AI space present risks that are creating a lot of fear. The nice thing in optimization is when we work with our clients, when they see the benefits and they see the potential benefits of it because they're quantifiable in terms of dollars saved or profits increased or time saved, et cetera, it's an easy argument to make. And the risks may come in. I like to tell a story of, if we're going to start, say we're doing a schedule and we're going to be scheduling a whole bunch of people, and we figure out that out of 1,000 people, you don't need 50 of them anymore and you can still operate your business. Well, we'll have a conversation with the HR department about, what are you going to do about these 50 people, right? So we try to really understand what are the downstream impacts. When we do our projects, we actually do a risk assessment along what we call it the Princeton 20. There's information on our blogs about this, where we evaluate 10 enterprise risks that are on the business side and 10 technical risks that factors to evaluate the risk, and saying, if you don't mitigate the risks associated with certain factors, you're going to fail. And this is based upon our 40 years of experience of doing these kind of projects. So we really try to do these risk assessments way up front so that we can identify ahead of time the things that we might occur as we get downstream. And that's why we use this Princeton 20 to really help us. And we think of it more of, we're developing a solution to a business problem, and the technology, AI optimization, machine learning, Chat GPT, we're starting to investigate applications of that as well. What problem is it going to solve? And by identifying the right problem and identifying the benefits, if we are to solve that problem, it makes it much easier to sell the projects and make our clients comfortable with the solutions we deliver.
Thank you so much, Irv. Well, as we're about to wrap up, Wade, do you have any more questions for Irv? Or
No, I appreciate your time. I think this is a really, topic that is a lot of people's minds. They get a flurry of media around AI, and this is obviously an area that, with logistics and shipping, and I mean, the military has been having to do this all for a long time. Because they have to move a lot of machinery and a lot of people and a lot of food and everything in a very short period of time. And so I know they have been a major funder of this kind of
Absolutely.
modeling and analysis. And then, of course, the big retail outfits now that have centralized warehousing, and now the customer is distributed. So obviously, this is an area that is very mature and stable, but still very much needed. And we just appreciate your time, and thank you for your insights to this community that watches our show.
All right. Well, thank you for having me.
Absolutely. Thank you. And before we go, let me just make a quick announcement, please. So tomorrow, tomorrow we're going to be talking right here on Tech Leaders Unplugged with, let's see who we have. No, that was No, we have. Sorry about that. We have the wrong graphic. Apologize. But we're going to be speaking with Harry Michelson, the co-founder and CTO of Hala.io. And that's tomorrow right here on Tech Leaders Unplugged. So join us tomorrow right here at 9:30 Pacific, and see you then and there. Thank you, Irv, and thank you, Wade. Talk to you soon. Bye-bye.
Yeah, bye-bye.
Bye-bye.